is homework 1.2, evaluating limits analytically. I'm going to help you guys out with number 3. I'm going to skip the first 2 because I feel like you should be able to do them, and if not, you should come talk about things because you have some conceptual issues that shouldn't be cleared up by a video. We're going to start with A of number 3, and it says to evaluate this limit, and this looks like a square root one where we might multiply by the conjugate, but the first thing we should always try is to directly substitute 3. So the first thing I'm going to try to do is put in 3 here, and I get the square root of 3 plus 1 over 3 minus 4, which doesn't give me 0 over 0. 3 plus 1 is 4, the square root of 4 is 2, 3 minus 4 is negative 1, and so this limit is negative 2. C looks like it's one of those fractions you want, but the first thing I'm going to do is I'm going to try to plug in negative 4, because just like in A, sometimes it'll work. When we plug in negative 4, we get 1/4 plus 1 over negative 4 over 4 plus negative 4. So in the denominator we get 0. In the numerator we get a fourth plus negative 1/4, which is also 0. And if we get 0 over 0 by using direct substitution, it means that the limit cannot be evaluated by direct substitution. That doesn't mean the limit doesn't exist. It just means the value there doesn't exist. So there could be a hole, and as you do the limit will approach a value. So we're going to use another technique. The first thing I notice here is that there's a fraction that I can combine, and so what I'm going to do is I'm going to try to get the same denominator so I can combine these fractions. I'm going to multiply by 4 over 4. My common denominator is going to be 4x. Here I'm going to multiply by x over x, and what I end up getting is x over 4x plus 4 over 4x equals 4 plus x. This is x plus 4 over 4x over, I'm going to rewrite this. I notice it looks a lot like the numerator. I'm going to rewrite it as x plus 4. The last thing I'm going to do is, this is a fraction divided by something, and that's the same as that same fraction times the reciprocal. And at this point we can see that we're multiplying by x plus 4. 1 is being multiplied by x plus 4 and divided by x plus 4. Those are inverses of each other, so we get 1 over 4x. Now, we should now try again to use direct substitution. We're doing the limit as x approaches negative 4. So we're doing the limit as x approaches negative 4 of 1 over 4x, and this can be done with direct substitution. It's 1 over negative 16. We don't leave negatives in the denominator. It is negative 1/16. On the back, let's do I. This is what our limits are going to look like in a couple of days, where there's stuff like this. This is doing a derivative. You just don't know it yet. When we plug in 0 by direct substitution, which is what we should always try first, we get square root of 1 minus 1 over 0. 1 minus 1 is 0. 0 over 0 tells us that this is the indeterminate form, and we're not going to be able to do it using direct substitution. So the next step you should look for is a way to simplify this, and this is one of those ones where you've got a square root, and so your first thought should be, I'm going to multiply by the conjugate. So the way that looks is, where the square root is, you want to multiply by the same thing, square root of 1 plus h, but instead of minus 1, we're going to multiply by plus 1. If we multiply by that in the numerator, we're also going to multiply by that in the denominator. And in the numerator, what we're going to get is, we multiply this, that'll cancel out the square root, and we get 1 plus h. We're going to get plus 1 times the square root of h minus 1 times the square root of h, and those will cancel out. We get square root of h, 1 plus h, minus square root of 1 plus h. The middle terms cancel out, which is what always happens when we multiply by the conjugate. So the last thing that will happen will be negative 1 times 1, which is minus 1. In the denominator, it really helps if you don't multiply it out. Just leave it as h times the square root of 1 plus h plus 1. Because in a second, what will happen here is we get h over h times square root of 1 plus h plus 1. and we're multiplying by h and dividing by h, and so we can cancel that out. That gives us the limit as h approaches 0 of 1 over square root of 1 plus h plus 1. And now we can just use direct substitution, plugging in 0. So we get 1 over square root of 1 plus 1, which is 1/2. The last one I'm going to help you guys with is letter K. K, again, we should always start by trying to do direct substitution. I'm going to show you how this should look in your head. When you plug in 2, 2 minus 2 is 0. 2 squared minus 4 is 0. So we have 0 over 0, and we don't need to write anything down. We just can move on from direct substitution. This sure looks like a factor and cancel one, so I'm going to start by trying to factor the denominator. So we get 2 minus x over, this is the difference of two squares. We should be pretty automatic about this at this point. X plus 2 times x minus 2, and I don't notice anything that can cancel here. 2 minus x looks a lot like x minus 2, but they are not the same. However, we can make the numerator look even more like this by factoring the numerator. What I'm going to do is I'm going to factor out a negative 1. So negative, well, the negative x becomes positive x, and the positive 2 becomes negative 2, and now I do have that x minus 2 term. So you should be on the lookout for, if you see 2 minus x and x minus 2, factor out a negative. And now we can cancel because we have the same factor in the numerator and the denominator. We get negative 1 over x plus 2. And we can just plug in 2 at this point. We can use direct substitution. And so we're going to get negative 1 over 2 plus 2, which is negative 1/4. So the last question asks, this is more of an AP problem. This is the kind that you want to be able to think through yourself. So if you haven't tried this for a while on your own, I would stop this video, go and try it, see what you can do, see if you can do some problem solving to figure it out, because you really want those skills to develop. This says, is there a number such that this limit exists? If so, find the value of a and find the limit. The first question is, well, is there a number that can make this limit exist? Well, the only way the limit won't exist is if we're dividing by 0. So I would try direct substitution first. So when we plug in negative 3, we're going to get 8 times 9 is 72 minus 3a plus 10 over, and the denominator will get 9 minus 3 minus 6. When we simplify that, that gets us 82 minus 2a over 0. Okay, so it sure looks like this limit isn't going to exist because we're dividing by 0. But remember, this limit can exist, the limit can exist, if it's 0 over 0, because that's an indeterminate form. So what this question is really asking us is, what value of a will make the numerator equal to 0? Because if the numerator is equal to 0, there'll be an indeterminate form, and we'll be able to evaluate the limit. So what we're going to do is we're just going to solve an equation. We want to know what value of a makes this equal to 0. That is literally the definition of an equation. 82 minus 2a equals 0, and we'll just solve it. We'll subtract 82 and divide by negative 2. We'll get positive 41. So if a is 41, we'll get 0 over 0, and the limit will exist. So that's the value of a. Now it wants us to find the value of the limit. So I can't find that from here. I need to go back to the very beginning, plug in my a, and try to do some limit tricks. So it's going to be the limit as x approaches negative 3. The limit as x approaches negative 3 of, I'm going to plug in a, 8x squared plus 41x plus, I'm going to combine a step here. A is 41, 41 plus 10 is 51, over x squared plus x minus 6. Now this sure looks like a factor and cancel one, so I'm going to start by factoring the denominator. It's going to be x plus 3 times x minus 2. This numerator looks way harder to factor, but I know that for it to be able to factor and cancel, I know that one of the terms has to be either x plus 3 times x minus 2, so I know since one of them is just x plus something, the other one has to be 8x. So that kind of helps me, and I'm going to look around for a second and think, is this going to be x plus 3? In which case this would be plus 17, and that works. So x plus 3 plus 17. The way I knew it worked is I was checking to see 3 times 17 is 51, and so it gives us the 51. This is 24 x's plus 17 x's, and that's 41 x's. The x plus 3 will cancel, and so we're left with 8x plus 17 over x minus 2, and we can use direct substitution. 8 times negative 3 is negative 24. Negative 3 minus 2 is negative 5. And so we end up with negative 7 over negative 5, which is 1.4. So A was 71, A was 41, and the limit was 1.4. There were a few other ways to do this that you may have stumbled upon. That's great, but this was a way.